The next thing we're going to do is just take a very basic look at the overview of the IR spectrometer and how it works. So modern IR spectrometers are generally Fourier transform infrared spectrometers, or FTIR is how they're commonly abbreviated. And we sort of have a diagram here of how this instrument works. But here's our sample. And down below the sample is a detector. And there's also a light source that's going to get passed through that sample. And what happens here is this light source actually first goes through a beam splitter. And the light beam is split and goes to a stationary mirror as well as a moving mirror. And that split light beam, after it bounces off the mirror, it comes back and these two beams recombine and go down into the sample, or go through the sample. Now this moving mirror is continuously moving, and of course the stationary mirror stays, and this beam that passes through is always the same. Now the light source that's actually being transmitted contains the whole sum of wavelengths. Okay, so we have all of those wavelengths, and what happens is when the light from the stationary mirror and the moving mirror recombine, depending on the position at that time of the moving mirror, that light can combine constructively or destructively. Okay, and this combination actually gives a wave pattern that passes through the sample, and that wave pattern is known as an interferogram. And every wavelength on the spectrum has a different interferogram. If the IR radiation at a certain wavelength gets absorbed when it passes through a sample, then the intensity of the interferogram for that particular wavelength is going to decrease, which then changes the interferogram that exits the sample, and then that's detected by the detector. Now the computer gets that interferogram, and what happens is it's able to decode it to actually produce sort of a traditional IR spectrum. And that decoding actually makes use of the Fourier transform technique. Now, the instrument that we have in our lab is actually sort of a more advanced form of the FTIR because it has an ATR accessory, or an attenuated total reflectance accessory. What that means is sample preparation is very, very simple. On this plate here, there's a small crystal, generally a diamond, and all you have to do is either place a drop of your liquid or oil sample on that diamond, or if it's a solid, you can put the solid on that diamond and then put this arm over to actually compress the solid down onto it. Now what this attenuated total reflectance does is it's designed in such a way that when light hits this crystal, at least one surface of this crystal allows that light to be reflected back into the instrument, which makes it very, very simple. And then all you have to do is just clean off the crystal with a little bit of solvent, and you're ready for a new sample.